Hello everyone, here are some more examples from section 6.1 where we get into something called second order differential equations where we're now given the second derivative and we have to work backwards to determine the equation for y. So I'm going to copy down this first example. Notice we're given our second derivative is equal to 2x plus 4. We're given two initial conditions, which are very necessary. One to help us find y, but the other one, which we want to first start with, is to find y prime. So we know to go from our second derivative to our first derivative, which we could call dy over dx, that's just going to equal the integral of 2x plus 4 dx. You don't have to write it that way. It's always good to. I know yesterday we weren't, or Friday we weren't, because we were just going straight to the antiderivative, which is fine too. So then this will just become x squared plus 4x plus c. So you could, like I said, call it dy over dx, or we could switch. It's a little bit easier to write to say y prime. Now we're going to use our initial condition that y prime of 1 is equal to 2. So now 2 is going to go in for y prime, and then we'll just get 1 squared, which is 1, plus 4 times 1, and then plus c. So c is going to equal a -3. So now we can say our specific solution for y prime of x here is going to equal x squared plus 4x minus 3. And now we build from that. We want to find y. And we'll take the antiderivative of this. So this is now just going to equal x cubed over 3 plus, we could start with 4x squared over 2 and simplify it next, and then just minus 3x plus c. Now just notice that these c's are different, so sometimes I even just call that d, just so we don't get confused. So we could do that. And then we'll use the initial condition here of y of 0 is equal to -1. So now we'll get -1. We'll just get a 0 for all three terms. So d is equal to -1. So now we have y is equal to x cubed over 3, or 1/3 x cubed. Then we'll get plus 2x squared minus 3x minus 1. And there's our specific solution for y. All right, so as I mentioned before, now this can apply to physics-based problems, so we're going to go ahead and do that. Here we're given, like our second derivative would be our acceleration function. So here a of t is equal to -16. S of 0, that's an initial condition, that's our initial position, is 3 at time t equals 0, and our initial velocity is 8. We want to find the position function. So if you want to pause the video and give this a try. And if you want more time, just go ahead and pause again. All right, so we're going to start with that a of t is equal to -16. So from that, we want to find v of t, which is just the integral of -16, and everything's in terms of t, so we'll say dt. So now this just becomes -16t plus c. And we'll use our initial condition that v of 0 is equal to 8. So now this means 8 is equal to -16 times 0, so that's just going to equal c, which makes sense. Our initial velocity is 8, so that's where that c is going to turn into 8. So now we have v of t is equal to -16t plus 8. Now we'll find our position function. So s of t is equal to the integral of -16t plus 8 dt. So this becomes -16t squared over 2 plus 8t. And we'll say plus d. And we could simplify this to a -8t squared if you didn't already go directly to that. and we'll find D. So again, we're using our initial condition here that S of 0 is equal to 3. So that means 3 is going to equal, well, this will become 0, 0. So D is equal to 3. So our position function is negative 8t squared plus 8t plus 3. All right, so we're just getting some more practice from section 6.1. Try these 4 problems. Also try AP pages 38 and 39, 25 and 26. And then without using a calculator, I want you to find the integral of cosine of 2x dx, so that 2x in parentheses there, same thing here, and then the integral of 4 sine of 2x dx. So remember I told you to look over trig identity, so maybe some of those can help. All right, so on the other videos, I will have the solutions for the AP page 18, number 5, and then a separate video just reviewing some problems from or what's upcoming on the Chapter 5 test on Wednesday. So you'll see a little video of that today and then another little review tomorrow. As always, guys, take care. Let me know if you have any questions.